Hey everyone, and welcome to another deep dive. This time, we're taking a look at something I think we all take for granted. Sleep. I've been reading through Chapter 3 of this book about sleep science, and I've got to say, I'm learning a lot. I'm joined by an expert on sleep today, so let's get into it.
Always happy to talk sleep.
So, something I think we all know. You walk into a room, see someone lying there silent and still, maybe snoring a bit, instantly that they're asleep. It's like we're all hardwired to recognize it.
Oh, absolutely. We pick up on all those little signs without even thinking.
Yeah. And this book actually breaks it down into like 5 key signs we look for. Like, are they lying down? Are their muscles relaxed? Stuff like that. But the question that really got me thinking was, how do you know you've slept?
Oh, yeah, the internal experience of sleep. That's a good
Mhm.
one. Not quite as easy to pinpoint as you might think.
No, not at all. The book talked about 2 main clues, though. First, there's that loss of awareness of what's around you. It's like the world just kind of shuts off. No more sights and sounds, no smells.
And it's fascinating because it's not just that those things fade away. There's a part of your brain called the thalamus that actually blocks those sensory signals from getting to the cortex. The part of your brain that makes you aware of them.
So it's like an active shutdown. Wow. That's wild. And then there's the whole time warp thing. Sleep really messes with our sense of time.
Yeah, that time distortion is something else. On the one hand, we lose track of time completely when we sleep. Like when you wake up from a nap and have to check the clock because you have no idea how long you were out.
Oh, for sure. Happens all the time.
Right. But then at the same time, it seems like some part of us is keeping track of time. How else would we wake up right before our alarms go off so often?
Right. Like my brain knows what time it is even when I don't.
Exactly. And you know what's even weirder? That time distortion is even more noticeable when you think about dreams. Ever notice how dreams can feel so much longer than they actually are?
Oh, all the time. Like a 20-minute nap can feel like a whole night's sleep in dreamland. It's bizarre.
There was this really interesting study done on rats that might help explain this. The researchers found that during REM sleep, when most dreaming happens, the brain is replaying memories. But here's the thing, it does it at half speed, or even slower, like quarter speed sometimes.
Wait, so our brains are basically hitting this slow motion button during dreams. No wonder they feel so long. That's incredible. Speaking of REM sleep, this book talks about how its discovery was kind of a big deal in sleep science, right?
Oh, yeah, absolutely huge. One of the biggest breakthroughs. It all started back in the 50s at the University of Chicago. These researchers, Aserinsky and Kleitman, were observing eye movements in babies.
So we're talking 1952, researchers watching babies sleep. And
Right. They noticed these periods of rapid eye movement, like the baby's eyes were darting back and forth under their eyelids.
okay, so what's the big deal?
Well, they realized that these rapid eye movements were happening during periods where the baby's brain waves were really active, almost as if they were awake. And then there were these other periods where everything was calm, the brain waves were slow and steady. That's what we now call non-REM sleep, or NREM for short.
And that's how we figured out there are different types of sleep. Wow.
Yeah, exactly. They called those periods of rapid eye movement REM sleep.
Amazing. So thanks to Aserinsky, Kleitman, and I guess we can't forget Kleitman's baby daughter, Esther, because she was one of the babies in the study, we know sleep is more than just one thing.
That's right. And further research found that NREM sleep actually has 4 stages, each one deeper than the last. And then, of course, there's REM sleep, which is when we dream. So it's not just one uniform thing, sleep. It's this intricate dance between these different states.
Which leads us to the sleep cycle, this 90-minute back and forth between NREM and REM that happens all night long.
Yeah, scientists actually mapped this out with a graph called a hypnogram. Picture like a line on a piece of paper. The line goes up and down as you cycle through the different stages of sleep.
Okay, I'm with you. But there's more to it, right? The book mentioned that this cycle isn't always the same. The ratio of NREM to REM changes throughout the night.
Exactly. Early on, when you first fall asleep, it's mostly deep NREM sleep. Stages 3 and 4, where your brain activity is super slow and you're really out of it.
Gotcha.
But then, as the night goes on, things shift. You start getting more REM sleep.
Okay, but why all this switching back and forth, and why does the ratio change?
Well, one theory is that it's all about memory management. It's like sleep is a sculptor, and your memories are the clay.
Interesting. I like that. So how does it work?
Deep NRM sleep, that's like the rough carving stage. Your brain is getting rid of all the excess, the unimportant stuff. Then REM sleep comes along. That's when the refining happens, the strengthening and connecting of the important memories.
So early in the night, there's a lot of pruning to do, so more deep NRM. And later on, the focus shifts to integrating those key memories, which is why we get more REM.
Exactly. A pretty amazing system when you think about it. Although there's a bit of a catch. According to this book, we might actually be losing more sleep than we think.
Oh, how so?
Imagine you wake up 2 hours early one morning. You might think, oh, well, I only lost 25% of my sleep. No big deal.
Yeah, that's probably what I'd think.
But, because REM sleep mostly happens in those later hours, waking up early, they can actually mean you miss out on 60 to 90% of your REM.
Whoa, that's a huge difference. I had no idea.
It is, and the same thing happens if you go to bed late. You miss out on that crucial deep NRM sleep. It's like trying to eat healthy but only having like one or two types of food. You need all those nutrients, and in this case, all those sleep stages.
Makes total sense. All right, so getting down to the nitty-gritty here, how does our brain actually create sleep? The book got pretty deep into the whole brainwave thing. Sounds like a pretty amazing show happening up there.
Oh, it definitely is. Picture this. You're in a sleep lab, hooked up to all these electrodes. When you're awake, your brain waves are all over the place, like a chaotic jumble. It's like listening to a stadium full of people all talking at once. Every neuron in your brain is doing its own thing.
Okay, so waking brainwaves are kind of all over the place. What happens when we start drifting off?
Things change. Big time. The brain waves slow down, become more rhythmic, more predictable. It's like that stadium crowd suddenly started chanting in unison.
Cool, visual. And there's also something called sleep spindles that happen during NREM sleep, right? What are those?
Oh yeah, those are like these little bursts of activity, kind of like a trill in the middle of all that slow, rhythmic activity. Researchers think they might be blocking out external noise, helping us stay asleep. Makes you wonder what our brains are trying to protect us from while we sleep, right?
Definitely. So even in deep sleep, our brains aren't just snoozing. It's more like an organized performance going on.
Absolutely. And you know what's interesting? Those deep sleep waves actually start in a specific place, right in your frontal lobes, about 2 inches above the bridge of your nose.
Really? I never would have guessed that.
And then from there, they travel like waves from the front of your brain to the back, gradually fading out as they go.
So it's not just about the rhythm, it's about the movement of those brain waves too. Mind-blowing stuff.
It is. You know how we talked about radio waves before, the difference between FM and AM?
Yeah, FM's high quality but doesn't travel as far, right? And AM's the opposite.
Exactly. Turns out waking brain waves are kind of like FM. They're high quality but don't travel very far within the brain. But deep sleep waves, those are like AM, lower quality but they can go the distance.
Okay, so those deep sleep waves are like long-distance calls happening inside the brain. But what are those different parts of the brain talking about?
Well, one of the main things they're thought to be doing is moving memories around. Deep sleep is like the time for transferring memories from short-term storage to long-term storage. Like waking is for taking in information and NRM is for thinking about it and deciding what to keep.
Interesting. So it's almost like waking is about taking it all in, and NRM is for processing it all.
Yeah, exactly. So what about REM sleep then? It's like we're going back to a state of wakefulness, but not quite.
Yeah, it's weird.
I know. Well, during REM sleep, the brain waves actually look very similar to waking brain waves, all fast and desynchronized. And in some areas of the brain, they're actually even more active during REM than when you're awake.
No wonder they call it paradoxical sleep. The brain's awake, but the body's asleep.
Right, and researchers think all that activity during REM sleep is about making connections, integrating those new experiences and memories with everything you already know. It's like your brain's building a model of the war during REM.
That makes sense. But then there's that whole muscle paralysis thing during REM. Why does that happen?
Oh, the atonia, think about it. When you're awake, your muscles are ready to move, right? They have tone. During NREM sleep, you lose that muscle tone gradually, but in REM, you're completely paralyzed. It's actually a really smart safety mechanism.
How so?
Well, during your dreams, your brain is sending out all these signals to your muscles as if you're really doing those things, but because of the atonia, you don't actually move. Imagine if you tried to run or jump while you were asleep.
Okay, yeah, that would be a problem. So it's like our brains are off in dreamland, but our bodies are safely tucked in bed. Makes sense.
It does, and sometimes when that system malfunctions, well, things can get a little interesting or even troublesome, but we can talk about that another time.
Ooh, a cliffhanger. Okay, well, before we go there, what about those rapid eye movements themselves? What's with all the darting back and forth?
For a long time, scientists thought those eye movements were literally following the visuals in our dreams, like we were watching them. But it turns out it's probably not that simple. Those eye movements actually seem to be part of the process that creates REM sleep itself, not necessarily tracking the content of our dreams.
So it's more about the mechanics of REM, not the dream itself. Huh. That's really interesting. I'm guessing we'll learn more about that later in the book.
We will, but for now it makes you wonder, doesn't it? Are humans the only ones with such complex sleep? Do other animals experience these different stages of sleep? Do they dream?
Those are great questions. I've always wondered if my dog dreams. I mean, he twitches and whimpers sometimes while he's asleep.
There's still a lot we don't know about sleep in other animals, but there's some fascinating research out there that might surprise you.
Well, in that case, I guess we'll have to keep this deep dive going and see where it leads us. But before we move on, listeners, I want you to think about your own sleep. Do you notice those changes in your sense of time? That muscle relaxation? Have you ever woken up from a dream that felt way longer than it actually was? Sleep really gives us a glimpse into how amazing and mysterious our brains are.
Absolutely. Even when we're seemingly still and unconscious, there's a whole world of activity happening inside our heads. It's pretty incredible.
It is. And on that note, we'll take a quick break. Join us for part 2 of this deep dive where we'll venture into the animal kingdom and see what we can learn about their sleep patterns. We'll be right back. So before the break, we were talking about those rapid eye movements during REM sleep, and it sounds like they're more than just a side effect of dreaming.
Yeah, they're not just some quirky thing. They're actually tied to the mechanisms that create REM sleep itself. Like they're part of the engine.
The book's being a little secretive about the details for now, but I'm definitely hooked.
Don't worry, the author promises to explain it all later on. But for now, let's zoom out a bit. We've been talking all about human sleep, but what about other animals? Do they experience these same complex sleep stages that we do?
Right. Like, does my dog dream? Do goldfish need their beauty rest? I've always wondered about that.
Great questions. We can't exactly ask animals about their dreams, but we can observe their sleep and their brain activity. And what we found is that all mammals and birds are signs of both NRM and REM sleep, just like us.
Really. Even creatures that are super different from us, like, say, a platypus or an owl.
As far as we know, yes. Of course, the exact patterns and how much time they spend in each stage that varies from animal to animal.
Makes sense. I mean, a lion probably has different sleep needs than a rabbit. Evolution and lifestyle probably play a big role.
Oh, absolutely. A predator needs to be ready to hunt. A prey animal needs to watch out for danger. But even with all those differences, that basic division between NRM and REM sleep, it seems to be pretty universal.
Wow, that's fascinating. So does that mean all these animals are dreaming too? Like if they have REM sleep, does that automatically mean they're having dreams?
That's where things get a little trickier. I mean, we can't ask them, right? But there's definitely some evidence that points in that direction. For one thing, during REM sleep, we see similar brain activity patterns in animals as we see in humans when we're dreaming.
So, like their brains are buzzing just like ours are when we're lost in a dream.
Right. And then there's the behavioral stuff. Ever seen a dog twitching its paws in its sleep? Or whimpering like it's chasing something?
Oh yeah, my dog does that all the time. He even barks in his sleep sometimes. It's adorable, but also a little creepy.
Exactly. Those kinds of behaviors, they suggest that maybe, just maybe, there's a dream world playing out inside their heads too.
So the animal kingdom is full of sleepers and maybe even dreamers, even if we don't fully understand what they're experiencing.
It really highlights how important sleep is for so many different creatures.
It does, but let's bring it back to humans for a minute. And we talked about all this science, the different stages, the evolution of sleep. But what does it all mean for us in our everyday lives? How can we use this knowledge to sleep better?
That's the million-dollar question, isn't it? Knowing about sleep is one thing, but actually putting that knowledge into practice, that's what really matters.
Exactly. We've learned that sleep isn't just about giving our bodies a break. It's about consolidating memories, processing emotions, even making sense of the world.
It is. And when we understand that sleep is a need, not a luxury, like eating or breathing, then we can start to prioritize it. And that can have a huge impact on our health, both mental and physical.
I love that. So instead of seeing sleep as something we have to catch up on, we should be looking at it as an investment in our well-being.
Exactly. It pays off in so many ways. More energy, better mood, sharper thinking, stronger immune system. The list goes on and on.
And it's not just about the quantity of sleep, but the quality too, making sure we're cycling through all those important stages.
Absolutely. It's like a balanced diet. You need all the nutrients, or in this case, all the sleep stages.
Okay, listeners, so what can you actually do to sleep better? Well, I challenge you to start paying attention. Notice how you feel after different kinds of sleep. What makes a difference for you?
That's a great place to start. Maybe it's adjusting your bedtime routine, changing your sleep environment, or even just being more mindful of your sleep habits in general.
It's all about finding what works best for you because we're all different.
Absolutely. And if you're really struggling, if you have persistent sleep problems, don't hesitate to talk to your doctor or a sleep specialist. Sleep is too important to ignore.
Couldn't agree more. Now, before we wrap up this part of the deep dive, there's one more thing about sleep that I'd like to explore. It has to do with the very definition of sleep.
Oh, that's a good one. We've talked about what it looks, how it feels, the brain waves, all that. But what is sleep, really?
Yeah, I have to admit, I never really thought about that before.
It's more complex than you might think. Scientists and philosophers have been debating this for ages. And as we've learned more about sleep, our ideas about what it is have changed too.
So it's not just as simple as saying sleep is when you're unconscious.
Not quite. For one thing, there are different levels of consciousness, even within sleep. Think about dreaming, for example. We're not fully conscious in the same way we are when we're awake, but there's definitely nothing going on up there.
Right. And there are those weird in-between states, like when you're drifting off or waking up. It's hard to say for sure if you're asleep or not.
Exactly. And then you have things like coma or hibernation. They share some similarities with sleep, but they're also different in important ways.
So where does that leave us? Are we just stuck debating the true meaning of sleep forever?
Not necessarily. While finding the perfect definition might be tricky, we can still focus on those key characteristics that we generally associate with sleep.
You mean like the loss of awareness of your surroundings, the time distortion, those distinct brainwave patterns?
Exactly. By focusing on what we can observe, we can sidestep those big philosophical questions and really dig into the fascinating science of it all.
I like that. Let's not get bogged down in definitions. Let's keep exploring, keep questioning, keep being amazed by this essential part of our lives.
Well said. And on that note, we'll take a quick break. Join us for the final part of this deep dive where we'll explore the core purpose of sleep and delve into why it's so crucial for our well-being.
We'll be right back. Welcome back to our deep dive into sleep. We've gone from those outward signs of sleep that we all recognize to the amazing world of brain waves and sleep stages. And we've even wondered about whether other animals dream.
It's been quite the journey, hasn't it?
It has, but there's one big question we haven't fully answered yet. Why do we sleep? What's the point of spending a third of our lives in this, seemingly passive state?
That's the ultimate question, isn't it? And the truth is, scientists are still figuring out all the pieces of the puzzle. But one thing's for sure, it's not just about resting our bodies.
Okay, so it's more than just recharging our batteries. What else is going on while we sleep?
Well, one of the most important functions of sleep is its role in memory. Remember how we talked about memory consolidation before?
Yeah.
Well, it's such a crucial process, it's worth digging a little deeper. During sleep, our brains are hard at work, sorting through all the experiences we had during the day. They strengthen the neural connections that are important and let go of the ones that aren't.
So it's like our brains are doing a massive cleanup, like tidying up our mental desktops.
That's a great way to put it. And that process, that memory consolidation, it's essential for learning. Whether you're trying to pick up a new skill, remember something important, or even just hold on to a special experience.
Makes sense. I always feel like I remember things more clearly after I've slept on it. Like those memories have had time to sink in.
Exactly. Sleep helps those short-term memories become long-term memories. It's like hitting the save button on your experiences.
So sleep helps us remember. But what about our emotions? Does sleep have anything to do with how we process those?
Absolutely. Especially REM sleep. That
Yeah.
seems to be a key time for emotional processing. During REM, our brains are revisiting those emotional experiences from the day, almost like we're replaying them and working through them in a safe environment.
That makes me think about those times when you wake up from a dream and you're still feeling those emotions, even though you know it wasn't real. Like if you had a nightmare, you might wake up feeling scared, even though it was just a dream.
Exactly. That just shows you how powerful those emotional processes during sleep can be. And by working through those emotions while we sleep, we're better able to manage our mood, reduce anxiety, and be more resilient to stress when we're awake.
So it's like sleep is a built-in therapist helping us process all that emotional baggage. Pretty amazing.
It is. And, the benefits of sleep go way beyond just our brains. Sleep is crucial for our physical health, too.
Right, we all know we feel more energized after a good night's sleep. But what's actually happening in our bodies while we sleep?
Well, during sleep, our bodies release a whole bunch of hormones. Hormones that help our cells grow and repair, boost our immune systems, and regulate our metabolism. It's like your body gets a nightly tune-up.
So it's more than just giving our muscles a break. Sleep is actively repairing and rejuvenating our bodies from the inside out. No wonder we feel so much better after we've slept well.
It's a vital part of staying healthy and functioning at our best.
I'm definitely seeing sleep in a whole new light now. It's not just a passive state of being off. It's an incredibly active and essential process that affects both our minds and our bodies.
Exactly. And when we start to see sleep as an investment in our well-being, we can start to prioritize it. And that makes a world of difference.
Well, we've explored a lot in this deep dive. We've talked about the science, the different stages, the evolution of sleep, the benefits, even how to define what sleep actually is. Any last thoughts before we wrap things up?
I think the most important thing to remember is this. Sleep isn't a luxury. It's a fundamental need, just like eating, drinking water, breathing.
So true. And when we don't get enough sleep, it's not just that we're tired. We're actually putting our physical and mental health at risk.
Right. So I really encourage you all, embrace the power of sleep, make it a priority in your life, and you'll be amazed at how much better you feel.
Great advice. And remember, there's a whole world of fascinating sleep science out there. So keep learning, keep experimenting, keep paying attention to your own sleep, and keep making it a priority. It really is an essential part of who we are. Thanks for joining us on this deep dive into sleep. Sweet dreams, everyone.